Hello. Today's lesson, we're going to learn all about this new thing called logarithmic functions. Logarithms are actually exponents. So the more you know about exponents, the better that you're going to be working with this new thing, logarithms. So first thing, I want you to be thinking about a logarithm in this very simplified version. Think a logarithm is an exponent. Let's review the pieces of what we already know in exponent world. If you have a number raised up to a power equal something else, like 5 squared equals 25, this thing has an actual name. We call that the base. And then the little number up to the right, we've always called the exponent or power. And this is the answer. I'm going to give you a fancy word for this one. Instead of answer, I'd like to think of it from now on as the argument, because that's the language you're going to hear in other videos if you look up information about logarithms. Now, a logarithm is this same idea written in a different format. And instead of saying the word logarithm every time, they shorten it to the word log. So we're going to rewrite this expression in this really neat new form. And I'm going to tell you the pieces of this. We are going to say logarithm base A of x is equal to y, or y is equal to logarithm base A of x. But I hope you heard the word base at least twice in that phrase. This little thing down here is the base, and in exponent world, this thing was the base. The answer to a logarithm is an exponent. So that is what used to be up here as the exponent is now going to be the answer to your logarithm. And then this has a special name. We're going to call that the argument. Please pause the video and write down what information you need on what these are all called when it's in exponential form and what each piece is called when it's in logarithm form. Our first thing that we're going to practice is changing from exponent form into logarithm form. So you can start by memorizing, and then as we venture into logarithm properties, it'll start to make more and more sense. Here, the base was 4, so when I rewrite it in logarithmic form, log base 4. In this one, the answer or argument was 64. The answer or argument in logarithm form goes here. And then the answer to a logarithm question is the exponent. The answer to a logarithm is an exponent. These are two ways of showing the same information. 4 to the third power is 64, or logarithm base 4 of 64 is 3. And as we proceed through the lesson, you'll get more and more familiar about why this is true. Let's practice one more time. If you have something raised up to an exponent equal a number, exponential form, you can rewrite it in logarithm form by remembering where the pieces go. The base of your exponent form goes down here at the bottom, becomes the logarithm base 100. The answer from your exponent form, the 10, becomes this, which we call the argument. And the answer to an exponent, answer to the logarithm is the exponent. Now, there is a trick that some teachers like to use, and they call it the snail. If I make this into the little head for my snail and then swirl around, and then you keep going like that if you wanted to, and give your snail little feet and antenna, that can help you with this idea that you can check your work by doing 4 raised up to the third power needs to equal 64. Let's try the snail check over here on this one. Is 100 raised up to the 1/2 power equal to 10? And you might want to refresh your memory on exponent rules, but 100 raised to the 1/2 does indeed equal 10, or you can look here, 100 raised to the 1/2 equals 10. We're going to try and go the opposite direction. I give you logarithm form, and you try to rewrite it in exponential form, something that you're more familiar with. If you use the snail idea, start with 3 and then create the shell that spirals around in a counterclockwise direction. So 3 raised up to that power needs to equal 9. And then you can check mental math, 3 squared is 9. Pause the video at any time to give yourself some time to write your notes. Let's rewrite the next logarithm. Instead of logarithm form, change it into this one, exponential form. Remember the base is 2 raised up to this power. The answer to a logarithm is a power. 2 to the negative third is equal to 1/8. We're going to review that in another slide, but it is true. 2 to the negative third is 1/8. Let's keep practicing this skill here. This one, we want to have what to start with, a base, but there is nothing there. So you're going to be responsible for remembering that if it just says log, L-O-G, no base, and then it goes straight to this called the argument, you have to memorize that all mathematicians are understanding or telling you no log base, no base number means insert a 10, then proceed. So this is actually given a very special name called common log. When there's no number there, it means there's a 10, and it's called common log. So the way to rewrite it in exponential form then would be 10 raised up to the second power should equal 100. 10 squared equal 100. There is one other very special kind of logarithm, and they give it its own special name. Notice how different this one looks. It does not say log, it does not say log base 2 or log base any number. It has ln and then just the argument. You need to write down on your paper and memorize that that actually means log base e. E is a number, and we can go over here to our calculator and ask our calculator, what number is e? And you also, there it is, I'll make it a little bigger, 2.71828. It's a number that continues on forever that you did see in your previous lesson. Now, the name for it when they do ln, which also can be represented as log base e, is called a natural log. You find it in nature in many different circumstances. Reminder that e is a number, approximately 2.718. Now, writing that in exponential form, we can take the base that we now know is e raised up to the 0 power is 1. Hopefully you are remembering that anything raised up to the 0 power is 1. Again, pause if you need to.